Determine the formula for the given sequence. Whenever we have a sequence of fractions, it's often helpful to analyze the terms of the numerators and the terms of the denominators separately to help build the formula. But also notice for this sequence, the terms alternate sign. Whenever we have an alternating sequence like this, we'll need to include -1 to the power of n or the power of n plus 1, depending on whether the first term is positive or negative. If we raise -1 to an odd power, we get a factor of -1. If we raise -1 to an even power, we get a factor of +1. But let's first focus on the sequence of the numerators, again ignoring the signs. In the numerator we have 5, 8, 11, 14, and so on. And notice in the denominator we have 6, 18, 54, 162, and so on. Let's first consider the sequence 5, 8, 11, 14. Notice we have repeated addition. 5 plus 3 equals 8. 8 plus 3 equals 11. 11 plus 3 equals 14, and so on. Because we have repeated addition, this is an arithmetic sequence where the common difference d is 3. This indicates we can use the formula a sub n equals a sub 1 plus the quantity n minus 1 times d, where a sub 1 is the first term, d is the common difference. To determine the common difference, which we already know is 3, we can take any term in the sequence given by a sub n and subtract the term before it given by a sub n minus 1. Notice 14 minus 11 is 3, 11 minus 8 is 3, and so on. The formula for the arithmetic sequence is a sub n equals a sub 1, the first term of 5, plus the quantity n minus 1 times the common difference d, which is 3. Let's go ahead and simplify this by distributing the 3 and combining like terms. This gives us 5 plus 3n minus 3, which equals 2 plus 3n. And now let's consider the sequence of denominators. Notice for this sequence, we have repeated multiplication. 6 times 3 is equal to 18. 18 times 3 is 54. 54 times 3 is 162. Because we have a pattern of repeated multiplication, this is a geometric sequence where the common ratio r is equal to 3. This indicates we can use the formula a sub n equals a sub 1 times r to the power of n minus 1, where again r is the common ratio. To check the common ratio, we can always take any term in the sequence given by a sub n and divide by the term before it, which is a sub n minus 1. Notice 18 divided by 6 is 3, 54 divided by 18 is 3, and so on. The formula for the geometric sequence is a sub n equals a sub 1, the first term of 6, times the common ratio r, raised to the power of n minus 1. So now if we find the quotient of these two formulas, we will get the correct terms of the original sequence, but the signs won't be correct. So now let's begin to build the formula for the given sequence. And now let's begin to build the formula for the given sequence. Again, because the signs alternate, we'll have to include -1 to the power of n or -1 to the power of n plus 1 as part of the formula. A sub n, let's try a sub n equals -1 to the power of n, and then for the terms in the sequence, we know we divide the formula for the numerator by the formula for the denominator, which gives us the quantity 2 plus 3n divided by 6 times 3 to the power of n minus 1. We should be able to tell right away this is not going to give us the correct sign. Notice for a sub 1, we'd have -1 to the power of 1, giving us -1 times the fraction from the formula, but notice the first fraction is positive, not negative. But that's an easy fix. We simply need to change the exponent on -1 from n to n plus 1. And now let's go ahead and test this. A sub 1 equals -1 to the power of 2, or the square of -1, times the quantity 2 plus 3 times 1 divided by the quantity 6 times 3 to the power of 1 minus 1, which gives us 3 to the 0. Simplifying, notice the square of -1 is +1, and then the fraction inside the parentheses is 5/6. Recall 3 to the 0 is 1. And this does give us the correct first term for the given sequence. Let's try one more. For a sub 2, we now have negative 1 raised to the power of 2 plus 1 or 3. So we have the cube of negative 1, and then times the quantity 2 plus 3 times 2, divided by the quantity 6 times 3 to the power of 2 minus 1 or 3 to the first. Notice now we have the cube of negative 1. Because we have negative 1 to an odd power, we get negative 1 times the fraction of 8/18. Recall 3 to the first is equal to 3. The denominator is 6 times 3 or 18. And this does give us negative 8/18, which is the correct second term of the sequence. So now we do have the correct formula for the given sequence. I hope you found this helpful.